This paper is talking about the challenge of reducing non-revenue water, a case study of Tirta Patria Water Supply Company in Blitar City. My name is Gregorius Nanda Yantika Nugroho. I'm from the Department of Environmental Engineering, Faculty of Civil Planning and Geoengineering, Institute Teknologi 10 November. Introduction. Tirta Patria Water Supply Company serves the drinking water needs of the people of Blitar City with raw water sources using groundwater taken from deep well. The value of unbilled water from Tirta Patria Water Supply Company is 68% in 2020. The high value of water loss has implications for not optimally increasing access to safe and proper drinking water, which can result in not achieving the full demand of affordability, continuity, quantity, and quality. In the context of the Sustainable Development Goals, increasing water uses and water use competition between social and economic activities have to be managed properly. Efficient use of water and environmental sustainability to maintain water sources are very important that implementing this SDGs as a whole. Responding to the challenge of the national target and SDGs, is it necessary to reduce the value of NRW? The value of NRW can be calculated and described in the tile using water balance tool. One of the tools in the calculating of the water balance is using VB-EasyCalc, where each component of the calculating follow the guideline of the International Water Association. This research is a case study reviewing the challenge faced by Tirta Patria Water Supply Company in reducing the level of water loss with scope of challenge calculating the water balance accurately. General description, the scope limitation cover the entire water balance of Tirta Patria Water Supply Company. There are 9 drinking water input systems which are divided into 8 zones. Each input system is interconnected so that it has one water balance. Drinking water balance requires serve around 6,000 house connections which are divided into 8 categories of host connections. For the material and method, data collection are data using secondary data. Data processing, the following are steps of data processing. Calculation of water balance follow the EVA procedure using the VB-EasyCalc tool. The data is one monthly data including system input volume, official account consumption, unbilled matter consumption, unbilled unmetered consumption, and unofficial consumption and inaccurate of water matter and data handling. Basically, for the calculation on revenue water is volume input system minus billed matter consumption, water losses is non-revenue water minus unbilled consumption, and real losses is water losses minus apparent losses. For the result and discussion, I will show you the definition of every component, the table of the calculation, the value of the calculation, and I will give you the recommendation from the problem that I found to calculating the water balance. And this is for the system input volume. We can see the result from system input volume value is around 247,000 meter cubic. I have two recommendations. First, to measure the amount of discharge at the input of the system whose main water is jammed with, we can replace calculation with a portable electromagnetic flowmeter device as a basis for a more accurate estimation for production capacity. And the second, replace the technology from mechanical meter to an electromagnetic meter. The margin error value can be increased to 0.15 until 0.5% or adjust the value stated in the main meter technical specification. And for the bile consumption, I use the secondary data and the result from the value of the meter account is around 77,000 meter cubic. And for the unmetered consumption value is just 16 meter cubic. And for unbilled consumption, I think this part I made a problem that can be fixed in the future. For the water balance calculation, it's found the unmetered consumption value is around 20,000 meter cubic. Future recommendation for developing water balance calculation, For unmet consumption section without billing, we can perform for flow velocity measurement at the location of the leaking pipe with a portable electromagnetic flow meter device as the basis for estimating flow velocity in the unmetered consumption volume calculation and recording it as flow velocity coefficient database. And next, for an authorized consumption, there are not primary data that I found in Tirta Patria, so I have future recommendation. The future recommendation for the developing of water balance calculation in the informal consumption section, we can estimate the amount of unofficial consumption and to carry out activities to track the number of things with real data in the field. To facilitate the scope of the area, we can reducing by searching just in maybe in one village with the number of condition with seal or unflow of the connection which is big enough. And the next, the problem for customer meter and inaccurate and data handling. For the VB cycle, the inaccurate value of the meter and data handling is around 11,000 meter cubic. And I have put a recommendation for developing the water balance calculation. Is necessary to record the age of the water meter whose data can be integrated with the customer database owned by Tirta Patria. The procedural model for replacing the customer water meter can be referred to attachment 2 to the regulation of the Minister Public of Work and Public Housing, number 4 of 2020, concerning of SOP for the implementing drinking water supply system section repairs. And for all data that I can handle with have a big of like data, I can calculation the water balance. So this is the water balance that I can calculate. So this is the result for data in February 2021 can be calculation for 68.52% NRW. We can make a specification. The apparent losses is 13.32% and the real losses is 45.59%. This is the conclusion. For the calculation of the water balance, the value of non-physical water loss is 13.32% and physical water losses is 45.59%. This value is the initial calculation value, and the accuracy of this result is still need to be improved. I will make a point. The accuracy of the result still need to be improved by increasing the primary data. Some data can be improved, including the increasing of the accuracy of system input volume calculation using an electromagnetic water meter, improve the accuracy of calculation of unbilled meter consumption with the coefficient of water loss due to leak handling, and recorded the estimating time for handling leak repairs. And the next recommendation is increase the accuracy of the calculation of apparent losses by searching for the primary data on the condition of water meter and calculating the coefficient of decline in its accuracy, sampling the area to look for illegal connection. I think it's enough all for me. I hope this paper have a benefit for Tirta Patria to calculate the non-revenue water. And if you have future another information for me, more information for me, you can contact me in email in gregoriusnfn@gmail.com. Thank you.